we will continue with what we started the previous lecture, motion along a straight line. Okay, everyone can see my screen?
Yes, doctor.
Not yet.
Okay, perfect. So we'll start by very quick revision.
Can't see.
No, doctor, we cannot see.
Okay. Let's see what the problem is. Oh, okay, here we go. Now we should be able to see the screen, hopefully.
Yeah.
Yes.
Okay, perfect. So my phone has run out of charge, so I don't have a second screen to see the chat window while I have the presentation. So if you have a question, try not to type it and ask it by voice so that I can stop and answer you. Okay, so we continue with motion along a straight line. Also, this is wrong. This should say chapter 2, not chapter 3. بداية غير مشجعة. Okay, so from the previous lecture, we recall that we looked at position time graphs, and we said that if we look at the slope of a position time graph, we get
Velocity.
Excellent. And that if we look at the slope of a velocity time graph, we get acceleration.
Acceleration.
Excellent. كلكم مذاكرين وكنتوا حاضرين وما نايمين. I like that. These three graphs are basically a summary of what we did in the previous lecture. Okay, so we can see that we start with a flat line in that was wrong. We start with a flat line in position. That gives us a flat line in velocity and a flat line in acceleration. Then we have an increasing line for position, which gives us a different value for slope at each and every spot, which gives us different values of velocity. Then we have a straight line in position, which gives us a straight line in velocity, and then everything goes in reverse again in velocity. Then we take the slope of the velocity. The slope of 0 is 0. The slope of this is a constant number, which is this. Here again, the slope is 0. So here again, we have all of this 0. Then we have a negative slope, which is this negative bit. And then we go back to 0. I heard a tongue, so I'm not sure if someone wrote something. Nope. Okay. Yeah, I know, I'm presenting. Okay. So let's start with a quick revision. Everyone to Moodle, let's start with a couple of quick PIQs to, get the blood flowing, to just do a very quick revision of everything we did in the previous lecture. I'll give you about a minute to get onto the PIQ. Be careful, this is a new PIQ this time. It's under today's lecture, not the previous one. It should say PIQ number 4. Okay, so let's do PIQ 1. Give you about, this is a very easy one, so what say we? About, not 2 hours, definitely not 2 hours, a minute and a half. Should be a quick one. order the speeds at times 1, 2, and 3 from the slowest to the fastest.
Doctor,
Mm-hmm.
the quiz is not opening on me.
Try refreshing the page.
Yes.
دكتور ما يشتغل معي.
ايش اللي يطلع لكم؟
نفس الشيء مع دكتور.
Are you sure you're PIQ 4 not PIQ 3?
ايوه دكتور.
بعده.
ايش اللي يطلع لكم؟
يتحمل بس يجلس ما عندنا يشتغل.
بطيء. Okay. Try refreshing. There's really nothing we can do about this except try. So we have about 101 people who have joined so far. And we have 118 people.
نفس الشيء مع دكتور ما يفتح.
It's quiet. Okay. Try refreshing. There is really nothing we can do except refresh because واقع الإنترنت في عمان. Okay. If you're unable to do it, at least look at the slide and try to do it on a piece of paper so that you're actually still part of the lecture and what we're doing.
But this quiz is part of our marks, right? Final marks.
Yes, but the question is a very tiny proportion, like 0.001%. And if you don't have a good enough internet connection, then you don't have a good enough internet connection. There's nothing we can do. So don't worry about the marks bit, okay?
I enter by my own network, not Wi-Fi. It's not opening.
Something is wrong then. I don't know why. Because 110 people have joined. That means only 8 people are still remaining that have not done it. Also, this is not one of those discussion questions, so don't worry about the marks for these ones. Okay. Okay, let's take a look. We do these to gain an understanding of how much we have understood or not. Don't worry about the marks for the time being, okay? Okay, excellent. Pretty much 90% of the students, 80% of the students answered correctly. You can see it's a very big difference between the correct and the incorrect answers. So that I am very happy about. So we want to look at the speeds at times 1, 2, and 3. We have a position time graph, which means that the velocity or the speed is the slope. This is, this is one slope, this is another slope, this is a third slope. The slope here is equal to 0. It's a straight line. The slope here is more than the slope here, which means that the speeds, this is the slowest, 0 is the slowest, then this, then this. Yeah, a very nice and simple question to get us fired up and started.
Doctor, please again.
So we have a position time graph. We have a position time graph, and we want to find the speed or the velocity, which is the slope of the line. So we look at the slopes. We have position 1, position 2, position 3. So position, slope. At position 1, our slope is positive, big. At position 2, our slope is negative, medium. And at position 3, our slope is simply 0. So in order from smallest to biggest, it is 3 is smallest, then 2, and the largest speed is at number 1. Okay. Now this one is a tad bit more involved. So this one looks at acceleration from a position graph. Next question. It should appear on your screens in 3, 2, 1, and it should be on your screen now. Let's see how good we can do this one. And I'll give you 2 minutes for this. So we look at a graph of position versus time, and we want to know which curve best represents a car that is constantly accelerating. Okay, a car that is accelerating all the time. So its velocity is constantly increasing. Here we have 112 participants, which means 6 people still haven't joined. Okay, pretty much everyone responded.
دكتور ما ظهر معك السؤال.
كيف؟
السؤال ما ظهر شكل النت.
دكتور ما يظهر عندي أنا.
حتى أنا دكتور ما شيء.
ما ظهر دكتور سؤال.
اوكي.
حاول تدخله من
لو
برنامج
تعيد دكتور بس.
I don't know how to start it again once it's ended. It's okay. Let's try with the next one. It's a touch and go situation, so there's only so much we can do. Okay, so most people actually did it well. So 82 people, actually I have almost pretty much everyone answered. Okay, so I have 82 people who answered correctly, option C, and about 16 people got the second best, which is option B. So let's take a look. Okay, let's consider these graphs. Now, we want to find something that is constantly accelerating. What does that require? If we have position and time, how do we find acceleration?
Change in the velocity.
Change in velocity. Okay, but we have a position. So what do we need to do to the position graph to get acceleration?
First find the velocity.
نشتق
derivative of the curve.
We get the
Find the
slope of the
slope.
position to get the velocity, and then the slope of velocity to get the acceleration.
Excellent. So we need to take the second derivative. So here's what we have. We have x, which is something. Then we need to find dx by dt to get velocity. And that needs to be changing. Then we need to do dv by dt and get a constant number, right?
Yes.
So let's take a look. Let's start with A. A is a straight line. So when I find the slope of the straight line, the velocity will be a single number, صح?
Yes.
Yeah.
So constant velocity. And if the velocity is not changing, that means there is no acceleration.
Yes.
So it means both A and B are out of the question. Then both of them will give me just a single number for velocity. It's not none of the curves. Actually, it might be none of the curves, but I'm telling you it's not. يبقى لنا C و D. Now D initially has a straight line, which means it's not accelerating at all the time. Oops. Okay, so yeah, so it's not D. The only possible option is C. We have a line that is constantly changing, which means if I need to find the slope at each and every point, I will get a different number at each and every point. So if I try to plot now the velocity with time, I will get this. I have something that the slope varies. Then I get a straight line, and that gives me a constant acceleration. Let's do it with an example. What does this line remind you of? This line like this, what does it remind you of? What kind of function from math?
Quadratic.
X square.
X squared, right? So
Yes.
نروح ورا يكون بهذه الطريقة. So let's say X squared. صحيح؟ ممكن نضربه في 5 في 6 في نسوي بلس اور ماينس، لكن بشكل عام X squared. معناته الفيلوسيتي بيكون ايش؟
2x.
2x. معناته الاكسلريشن بيكون فقط
2.
constant. right? لما كان عندنا بهذه الطريقة يكون عندنا y equals ax، معناته الفيلوسيتي يساوي خليني استخدم حرف ثاني بدل a عشان ما نتلخبط، بستخدم سمايلي فيس x، معناته ال v بيستوي سمايلي فيس، معناته الاكسلريشن يساوي 0. صحيح؟ واضحة؟
Yes.
We're going to be using this over and over again, the idea.
Yes.
Okay, good. Now let's see if I have any questions in it. Nope. Okay. All right. Should we do this? Nope. You pretty much all of you got this one right. So I'm going to skip PIQ3 and I'll go to the next one. Okay. Here's a question. At time t equals 0, a car is at some position and has some velocity. Now, if the object has a constant acceleration a, what will be its final velocity and position at some later time? So this is the information we know we have عندنا السرعة الحين، عندنا الموقع الحين. We know what the acceleration is, and the acceleration is constant. It's not changing all the time. We want to know after some time, what is the velocity? What is the position? How do we find that out? So this is the whole point of what we've been doing so far. We want to find an equation that describes how things move and how systems evolve. صحيح?
Yes.
So we want to know, okay, how do we find these things?
T times 8 plus V0.
Okay.
Or by integration.
Or by integration, that's also possible. Let's try to derive it from first principles. Okay. To get an idea, I know you have seen this equation in the book, but the question is, how do we get it? Okay, and the book does a good job of explaining it, but I will derive 2 out of the 5 equations for you from first principles. And actually, I'm not going to derive it for you. We're going to derive it together. So you are going to be doing the derivation for me. I have a question. I have something which starts at 0. I have a car that starts at 0. Okay. And it accelerates at 3 meters per second square. Can you help me out? Fill in this table. Can you help me out?
Yes, doctor. After every second, the velocity will increase 3 and 3.
So وبعدين يصير عندي 3 وبعدين
6 9
كذاك؟ ممتاز. Let's try and draw this. Okay, let's draw this. We have a set of data. Let us draw it. So this is time. This is velocity. Okay. Can you help me draw it? So where is 0 0?
The origin.
Origin.
So 1 3. So 1 2 3 4 5. وبعدين هنا بيكون عندي 3 6 9 12 15. And what I end up with is this. صحيح?
Yeah.
Okay, now just as you did in your labs, okay, I will draw a straight line. Now I'm not very good at drawing, so my straight line is not going to go through all the points, but it's supposed to go through all the points. Okay, now if I want to give this straight line an equation, what is it going to look like?
Y equals
equal mx
plus
plus
intercept of y.
So y equals mx plus c. صحيح؟
Yes.
خلينا نعوض الحروف الصحيحة. ايش الواي في هذا الرسمة؟
velocity.
velocity. خليني اغير اللون. velocity. ايش الام؟ ايش السلوب؟
acceleration.
وايش الاكس؟
time.
وايش السي؟
v naught.
اللي هو السرعة at time equals 0. And now you have by yourselves derived the equation of motion for an object that is moving constantly at a constant acceleration. V equals V naught plus AT from first principles. Very simple, صح?
Yes.
Okay. Now, what if I want to derive what is the distance traveled during this time? What is it going to be? Any idea?
Can you repeat the question, Doctor?
Speed multiplied by time.
So I have the time, I have the velocity, I have an equation that describes how my velocity changes with time. What if I want to know at time equals 4 seconds, كم المسافة اللي قطعناها?
Multiply it by
Take the area under the graph.
Okay, that's one option. Take the area under the graph. What's another option?
Should we write the equation which give us the velocity from the first place?
Okay, بعدين.
And then we do the same for the acceleration, and we make it as the equation which give us the acceleration, and that might be we continue as well.
Integration.
Okay, yeah, that is a very good. Those are all very good options that you mentioned. One option is the simplest equation we know is that
D equal V multiplied by T.
V times T. Now, if V does not change, هذا الإيكويشن عال العال 100 على 100 صحيح؟ إذا أنا أمشي على constant V 10 أضرب 10 في الوقت وطلعت المسافة، أمور طيبة. لكن إذا ال V يتغير it starts becoming a problem لأنه على كل T ال V مالك مختلف. فمعناته لازم نشوف على كل T إيش ال V، على كل T إيش ال V، ونضرب ونجمع ونضرب ونجمع. Otherwise known as, one of you already figured out the answer. We simply take the area under the graph. This is our distance. صحيح?
صحيح.
Okay. What if I don't have a graph? أيوة.
ما ممكن بالتكامل؟
ممكن أيضا بالتكامل. Let's do it. Let's actually do it together. Okay. So I have my equation اللي انتوا اشتقيتوها V equals U plus AT. أنا راح أستخدم شوية نوتيشن مختلف عن الكتاب. بدال V نوت أنا راح أكتب U. طيب علشان أفرق ما بين ال V final اللي بكتبها V وما بين ال V initial اللي بكتبها دائما U. تمام؟ علشان ما نتلخبط بين V و V نوت و VI و VF ما يكون عندنا 600 V في سطر واحد. V equals U plus AT. طيب تعالوا نكملها. What is going to be our variable of integration? D what?
T.
dt. dt. We want to go from velocity to distance. رايحين نريوس صح؟ So كيف ما كان عندنا distance، خلينا نرجع فوق شوية. نحن سابقا كان عندنا distance عملناه dx over dt تحول إلى velocity صحيح؟ معناته إذا نبغى نرجع نكامل نعمل v dt تكامل بيعطيني distance. تمام؟ So far so good?
Yes.
اوكي جميل جدا. خلينا نرجع. طيب what are our limits of integration going to be?
0 to 4.
0 to t. From time 0 to time t صح؟ صح ولا ما صح؟
Yes.
Okay, let's do. V dt will give me what? Will give me V t from time t to time 0 equals ut from time t to time 0 plus at squared على 2 0 to t. صحيح؟ ايش قلنا VT؟ What is VT؟
X.
X. صحيح؟ راح ناخذ هذه ونجيبها هنا. فبيصير عندنا X at time t minus X at time 0 يساوي ut minus u صفر plus at squared على 2 سالب a صفر تربيع على 2. So far so good. Are we happy with everything so far ولا أنا مسوي غلطة في مكان ما؟ So far so good.
Yes دكتور.
Okay. هذا صفر وهذا صفر. معناته our final equation is going to be
دلتا اكس
minus x naught أو نكتب دلتا x أو أنا أستخدم حرف الS بالعادة يساوي ut plus half
AT سكوير
اللي هي area under the graph واللي هي أيضا هذه this is your equation.
دكتور
أيوة
نقدر ناخذ المسافة من تحت المنحنى بدون تكامل، يعني مثلا نصف قاعدة في الارتفاع قاعدة
أيوة.
المثلث.
إذا الشكل سهل why not go for it. إذا الشكل مربع مستطيل مثلث باراليلوجرام شيء كذاك perfect نور على نور.
وإذا منحنى
إذا منحنى تصير صعب إنك أنت تأخذ، لذلك تعمل بعدين التكامل. لكن خلاص أنت الحين التكامل عملته بدون ما تعتمد على أنه مثلث أو مربع أو مستطيل، صحيح؟
صحيح.
أنت الحين لما كاملت أنت ما اعتمدت على أنه مثلث أو مربع. فthis equation will work in all situations where the acceleration is constant. Okay?
Okay.
تمام. Because when your acceleration is constant, you always have a triangle. Okay. All right. Let's go back to our presentation. And voila, here are your equations in the book that you derived on your own. So I will write it using my way as well, in case you want to use, you know, the way that I write. If not, then that is fine. It is entirely up to you. Here we go. Okay, so we derived from first principles, we derived 2-11 and 2-15. عملناها من first principles بدون ما نعتمد على الكتاب، بدون ما نعتمد على شيء. From first principles. Now these equations, okay, work at all times if the acceleration is constant. ولكن هذه نقطة مهمة. Make sure the acceleration is actually constant قبل ما نبدأ نستخدم هذه المعادلات في أي مسألة، وإلا you get a nightmare. Okay. Now, these equations might look difficult. They might look quite a bit. I have two pieces of news for you. One, that in the exam, whether you're talking the midterm or the final, you will be getting a full formula sheet for all the equations in this course. So you do not need to memorize the equations at all. The second piece of news is that we are going to be doing so many problems with these equations that by the end of chapter 4, this will be like second nature. You will use it without even thinking about it. Okay.
Great.
Okay. Now let's do a practical example. Let me see first if anyone has sent anything. Okay. No. So back. Okay, let's look at a problem and solve it using these equations. Bismillah. A red car and a green car, identical except for color, move towards each other in adjacent lanes and parallel to an x-axis. So far, so good. At time t equals 0, red car is at x equals 0. So we are defining our axis هنا. This is our 0 point. Okay, so at t equals 0, xr equals 0, green car is at xg equals 220 meters. If the red car has a constant velocity of 20 kilometers per hour, now if red 20 kilometers per hour, meet at 44.5 meters. If red 40 kilometers per hour, meet at 77.9 meters. This is 44, this is 77.9. What are the initial velocity and the constant acceleration of the green car? So the red car is going at a constant velocity, إما 20 كيلو في الساعة أو 40 كيلو في الساعة. The green car starts with some velocity, we don't know what it is, and it keeps accelerating, and they either meet at 44.5 or at 77.9, depending on what the velocity of the red car is. What is the initial velocity and what is the constant acceleration of the green car? Now, at first instant, this might look like a really difficult problem. نحن ما عندنا معلومات. حي الله عندنا 2 pieces of information, 3 pieces of information. That's it. How are we supposed to get this? First thing first. What do we do in any problem when we have quantities? We said it last week.
Write them.
We wrote them down. Then?
Standard.
Standard. So 20 kilometers per hour is 5.56 meters per second. 40 kilometers per hour is 11.1 meters per second. No, I did not do it in my head. I actually cheated and I have a calculator here. Okay? Okay. Now, there's one more piece of information that is crucial to do this question that is not written down, and that we need to use our heads to get. For 2 things to meet, what are the 2 most important conditions in life?
Same velocity.
Same time. They pass the same point.
Okay.
Position and time.
Position and time. For you to meet your friend لازم تكونوا في نفس المكان في نفس الوقت، صحيح؟ إذا كنتوا في نفس المكان لكن في أوقات مختلفة ما راح تتلاقوا. إذا كنتوا في نفس الوقت لكن في مكانين مختلفين ما راح تتلاقوا. ممكن سرعتكم تكون مختلفة، ممكن تسارعكم يكون مختلف، ممكن واحد فيكم جاي يمشي على رجوله والثاني جاي يمشي على يده. I don't know, it's fun day. All of these doesn't matter. But the 2 most important bit is what? لازم تكونوا في نفس المكان في نفس الوقت. So there's a key point. أنه XR لازم يساوي XG في نفس T. And this is all we need to solve this problem. How? Why? What are we going to be doing? We have our equations. I will write them down. I always write the equations in the corner. V equals U plus AT. V squared equals U squared plus 2AS. And S equals UT plus half AT squared. I rarely use the other equations. Okay, I always write them in the corner. Now, what do we do with them? Well, we know XR initial is 0. We know they meet at 44.5 meters مرة or at 77.9 meters مرة ثانية. We don't know what the velocity initial here is. We don't know the acceleration of the car is what. What else do we know? We know that V is equal to 5.56 meters per second or 11.1 meters per second. And we know that X initial for this is 220 meters. Sahih? Now, key point. Same place, same time. Same X, same T. Okay? So, here I have V equals U plus AT. هنا عندي V equals U plus AT. My velocity here is constant. So it will be 5.56. My initial velocity, actually, this makes no sense here. This equation makes no sense here because I don't have acceleration, صحيح? So v equals u. But here we have v equals u plus 80. Let's look at the first one. V equals 5.56. Now we know distance equals velocity times time. وهنا velocity constant. معناته time equals 5.56 على distance اللي هو 44.5 meters يساوي أو 11.1 على 77.9. 5.56 divided by 44.5 is, لا, did I do something wrong? x over v, صح؟ مش v over x. أنا غلطت وما حد نبهني يا جماعة. ده أنا وقعت وما حدش سمع علي. So it needs to be 44.5 على 5.56 and 77.9 over 11.1. And what am I going to get for time?
8 seconds.
Okay. And for the other one, 7 seconds, I think.
Yes.
Okay. And now we have key points of information. على 8 ثواني, they both need to be at 44.5 meter. أو على 7 ثواني لازم both يكونوا على 77.9 meters. صحيح؟
صح.
ممتاز.
Yes.
ممتاز ممتاز ممتاز. Now I have two sets of equations here. بستخدم v equals u plus 80. Actually, can I use this? I don't know v, I don't know
No.
u, I don't know a. No, I can't use v equals u plus 80. Which one can I use?
The last one?
I can use the last one, right? S
Yes.
equals ut plus half at squared. Yeah, that one is very possible. Now بما أنه نحن بدأنا من 220 متر لما نوصل 44.5 كم متر نكون مشينا؟
265.5.
175.5 صحيح؟
Yes.
So I have 175.5 equals 8u زائد half a 8 squared. In the second case, 220 minus 77.9 is 142.1. يصير عندي 142.1 equals 7u plus half a 7 squared. Now from mathematics, we know if we have two unknowns and two equations, what can we do?
Simultaneous.
We can use simultaneous equations to solve them together. Now I'm not going to solve them. You can do it yourself. Okay? Okay. Yes, you're excellent students. We have already discussed this beforehand.
Doctor,
Aywa?
do we have to focus on the significant figures and decimal places while answering such a questions?
I would say no. Generally no. But there is a very important point that many students tend to neglect. Okay? We don't focus on the significant figures and decimal points as we do in the lab. ولكن there are situations where they are important. And I'll actually tell you something that happened in the previous semester, which will be very useful for you. إيش الفرق? Let me actually write something. أنا سويت مسألة حسابية طلع الجواب هذا. كيف أكتبه على ورقة الامتحان؟ قولي مثلا velocity meters per second. كيف أكتب هذا في الامتحان؟
3 significant figures.
2 decimal place velocity.
Okay, 2 decimal place. One person said 3 significant figures. What else?
0.3 والخط اللي فوق.
depends about equation.
والخط اللي فوق اللي هو recurring ممكن جدا اذا انت تعمله مثلا على ورقه، ممكن الكترونيكلي شو ما تقدر تحط هذاك الخط. عندنا اوبشنز، ممكن نكتب
1/3.
ممكن نكتب 1/3 صحيح، لكن اذا ما نريد نكتب 1/3 لاي سبب من الاسباب يا اخي، نريد نكتبه بهالطريقه ديسيمال. كيف نكتبه؟ ايش الفرق ما بين 0.3 0.33 0.333 و 0.3333؟ ايش الفرق بينهم؟ بين كل واحد والثاني؟ Most of us don't know that.
حدد أكثر.
أنت تحدد أكثر، بس نسبة التحديد كم تختلف؟ Have you ever
0.01
about it? Let me show you. 0.333 تقسيم 0.3333 يعني الفرق ما بين آخر واحد من هذا لهذا، أنت نسبة التطابق عندك 99.9%. من 0.33 إلى 0.333 نسبة التطابق عندنا فقط 99%. وما بين 1 decimal place و 2 decimal places كم تتوقعوا الفرق؟ كم نسبة التطابق؟
98.
90%. يعني إذا أنت الجواب مالك 0.3333 وأنت كتبته 0.333 ما فرقت واجد. You are only 0.1% off. إذا كتبته 0.33 you are 1% off. لكن إذا أنت كتبته 0.3 إيش سويت؟ You are 10% off. It's a big difference. صحيح؟
Yes.
The usual rule of thumb that I always advise students in calculations, do not round. Final answer, 3 significant figures is usually a safe bet. For the final answer, 3 significant figures is usually a safe bet.
Doctor, 3 significant figure or 3 decimal points?
3 significant figures is usually a safe bet in 99% of the situations. Okay. ولكن use your common judgment, common sense. Okay. يعني إذا الجواب مالي مثلا 2978.62. Okay. Use your common sense. 2980 ما مشكلة. 29779 ما مشكلة. طيب. لكن 3000 is a bit off. طيب. أو مثلا ممكن you go always مثلا to. يعني there are situations where you need to use your common sense. يعني لما الجواب يكون فيه 4 أرقام وبعدين نقطة، مختلف لما الجواب 0 وبعدين كل الأرقام بعد النقاط. صحيح؟ هنا 3SF is usually a good bet. هنا يعتمد كم رقم عندك. أحيانا 3SF is too little. You need to go for a bit higher. أوكي؟ بس لا، ما فيها محاسبة مثل اللعب. If that was your question. Okay. So area under graph is the distance. We already did this. This is what we already did. So the area, the integration gives us the area under the curve. This we also did. Let us skip this and let us talk a little bit about freefall. Okay. What did I do? Okay. I will tell you a statement and you tell me if it is true or not. everything that falls at the same acceleration, at the same rate.
True.
Yeah.
Okay.
True. Yes, true.
It depends.
It depends.
No, it's true.
Okay. Let me try another sentence. Aywa?
It's true
Given
if
the
we didn't
density
consider
or
the
mass.
air.
Okay, so it's true if we don't consider the air. Okay, fine. Let me try another sentence. Everything that falls at the same velocity.
No.
False. No.
False.
No. So some of them more, some of them less. Okay. Okay, what else? But I have a question. If they fall with the same rate, why do they not fall with the same velocity?
The mass effect.
Different. The initial
Mass
velocity.
effect. Gravity effect.
The difference of the weight.
The same velocity.
The same velocity. When some people said difference of weight. Let me show you a video.
When there's no air, the mass doesn't matter.
Okay, so when there's no air, the mass doesn't matter. Does that mean they all accelerate at the same rate?
Yes.
And
No.
does that mean they have the same velocity?
Yes.
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 No.
No.
No. Okay, let's look at a video and then we can talk about it. Where is, okay, so first thing first. First thing first, I will stop my video so that you are going to be working with less bandwidth. Can you hear?
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum. It's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take the force that's present on the outside when it's...
Yes?
It's very laggy. Can we just watch it on our own laptops and then you can ask us questions about it?
Okay, is it very, very laggy for everyone?
Yeah, we can't see anything.
Yes.
Okay, in that case, let's do something.
When it's pumped out to the condition.
Okay, let me do something then. Okay, can you all copy this? I will put it on a notepad. Okay.
Can you just paste it on the chat?
Or that. That's
Sir,
actually
present only the tab of Chrome. Only one tab. It's perfect for videos.
only one tab.
Yes, when you present the screen, it's ask you if you want to present a tab or Windows or the whole screen.
Does it make a difference in terms of?
Doctor.
Yes,
the
it's
video.
the best for videos.
Okay, let's
The
do
video
that.
is in Moodle.
The video is also in Moodle. Yes. Okay, let's see
Yes.
if we can do this now.
Missions out of space.
It's clear.
Is it laggy? Or is it clear now?
It's
Okay.
clear, mister.
Okay, so this guy was saying something. Okay. He was talking about why aluminium was a bad idea to make this chamber out of. What is the problem if I take the air out of a chamber?
Too much pressure.
Too much pressure, right? If I take all the air out of a water bottle, it will crush the water bottle, right?
Yes.
It's like what happens to chips Oman if there's a hole and all the air comes out. You end up with harissa instead of chips. Okay, so what these guys had to do was put concrete to withstand the pressure, because can you imagine a full building pumped out of air? The amount of pressure on it is huge. Okay, now let's look at this, because this is actually really, really important.
Isaac Newton would say that the ball and the feather fall because there's a force pulling them down.
So I really, really wish we were in a lecture theater or your cameras were on, because I am pretty sure quite a few of you would be smiling at the moment. So what did we learn? In vacuum, when there's no air resistance, what happens؟ سوينا لكم شوية جو وفيلم رعب وآخر شيء يتحول إلى موسيقى رومانسية وكلهم طاحوا نفس الوقت. What did we learn?
Mass doesn't matter.
Math is not my deal.
So in vacuum, mass doesn't matter. They all fell down at the same time with the same acceleration with the same velocity, and they hit at exactly the same time. Okay, which is, well, I don't know, but I found it really exciting. I mean, although we know it, you know, in theory, but when you actually see it in a video, it's actually exciting. Okay, so what we learn is I want to do something to see if I can make it any better for you. Okay, so can everyone see my screen again?
Yes.
Yes.
Okay. For those
Yes,
of you,
clear.
for those of you who are on a mobile phone and are using 3G or 4G connections and are on limited data plans or are experiencing significant amounts of lag, what I suggest you do is you go to this hamburger sandwich option, the 3 dots, more options here. You go to settings, video, and in receive resolution, okay, you put standard definition. Don't put automatic, put standard definition 360p. So what that will do is that will make you receive a lower quality video, which means less lag for you if your connection is not as strong. And also it means that if you're on a mobile connection, if you're on a mobile phone, 720p and 360p, it will not make much of a big difference. And if you're using, you know, اشتراك محدود, this will save you a lot of money. Okay, and you can do this in all your lectures, not only this lecture, because أعرف إنه معظمكم ماخذ 4 أو 5 مواد وعلى 10 محاضرات في الأسبوع. That's a lot of data to consume on a mobile phone. Okay, so this will reduce your bill by maybe, you know, to the half or by 60% at least. Okay. So we learned that in vacuum, all falling objects do have the same constant acceleration. And that is on Earth about 9.81 meters per second square. Okay, or 9.8, give or take, 9.81 meters per second square. Okay. Now, yes, because of air resistance, things do turn out a little bit differently, but we will talk about that a bit later. Now, there's a question that students ask me. G is plus 9.81 ولا minus 9.81؟ نحن متلخبطين. احيانا كتاب يقول plus 9.81، احيانا يقول minus 9.81، الدكتور الفلاني قال plus، الدكتور الفلانيه قالت minus، راسنا عورنا ونحن بعدنا ما عارفين هذا الشيء plus or minus. Okay, so here's what happens. Whenever we solve a problem in physics, we need to define what we call a coordinate system. So X Y. احيانا عندي سؤال حالكم وممكن يكون هذا سؤال سخيف بس استحملوني وجاوبوني. ايش اسم هذا الاتجاه؟ أب. ليش؟
شمال.
ليش
شمال.
شمال، فوق، أب. ليش؟
فوق لأنه
على حسب موضعنا هنا.
ليش ما اسميه داون؟
لأنه فوقك.
بالنسبة عرض
يعني انا ابغى اسمي هذا تحتي. كيفي؟ هذا تحتي وهذا فوقي، ايش رايكم؟
عادي.
according to the gravity.
انزين ويش اللي خلى هذا الاتجاه نسميه فوق؟ ايش معنى؟
عكس الجاذبية.
عكس الجاذبية. طيب ما لازم انه يكون عكس الجاذبية فوق، ممكن اسميه تحت.
لأن احنا باين انه يكون فوق.
لأنه غالب الأوضاع اللي احنا نعيش فيها هذا هو الاتجاه الأعلى.
أقول لكم شيء، خلونا من أعلى وأسفل وفوق وتحت. أنا بسميه شيء، أنا بسمي هذا الاتجاه غرشة وبسمي هذا الاتجاه ستيبلر. فيها مشكلة؟
عاد لا عادي عرفت.
خلاص
شوف اللي يناسب.
طيبة.
حنا معي.
ايوه بس لازم تحضر البقية.
ما مشكلة لكنه غير عالمي.
زين، هو على غير العادة، غير طبيعي، معظمكم بيقولوا هذا جن. انزين، لكن هل يغير شيء في الحياة؟
لا.
هل يغير شيء في الفيزياء؟ في كل الأحوال يوم أنا أترك شيء بيطيح في هذا الاتجاه، صحيح؟ سواء أنا سميت هذا الاتجاه تحت ولا سميته فوق ولا سميته سمايلي فيس ولا سميته ستيبلر، هو في كل الأحوال بيطيح ذاك الصوت. المسمى اني انا سميت هذا الاتجاه فوق وهذا الاتجاه تحت، انزين، هو مجرد مسمى. انزين، وما هي الا اسماء سميتموها. انزين، بس ما بكمل بعدين بتقول كفرتنا. المسميات ممكن تختلف لكن الايكويشن doesn't change. The equation stays the same. Why did I ask this stupid question? Okay, because many times students ask me, Doctor, G is equal to 9.81 ولا minus 9.81? The answer is it all depends on how you define your coordinate system. Okay, if it's up to you. This is your XY axis, صح? This is your XY axis. You define what is up, what is down, what is plus, what is minus. If you decide this is plus and this is minus, then your G will be what? Minus 9.8 meters per second squared, صحيح؟ طيب أنا غيرت رأيي. أنا أبغى أسمي هذا minus وهذا plus. And this makes sense in a lot of problems where you are throwing stuff. It makes things easier. Now what is G? Plus 9.8. ولكن فيها شرط. ما يصير تغير رأيك. Once إنك قررت أي اتجاه plus وأي اتجاه minus ما تقدر تغير رأيك في بقية المسألة. يعني لازم everything follows that convention. So, if I choose this convention for any reason whatsoever, okay, my G is 9.81 ولكن بداية المسألة أنا أخذ كرة واعقها فوق. What is the distance the
Negative.
ball moved? Minus. So إذا الكرة ارتفعت ل 100 متر, my distance will actually be minus 100 meter.
What about the velocity?
فوق سالب. تمام؟ وضحت الفكرة؟
نعم.
وضحت.
No. أي جزء من الفكرة ما واضحة؟
كيف فوق سالب؟
أنا عرفته إنه سالب.
زين دكتور في المسائل نعوض بالسالب؟
يعتمد. أنت عرفت فوق موجب ولا أنت عرفت فوق سالب؟
زين في الكتاب مكتوب do not substitute minus 9.8 ACG.
وين مكتوب في الكتاب هذا؟
في البلو بوكس.
Do not. خلينا نشوف. The free fall acceleration near Earth's surface is A equals minus G minus 9.8, and the magnitude of the acceleration, do not substitute 9.8.
minus 9.8.
Do not substitute minus 9.8 for G. أقول لك شيء؟ الكتاب ما صاحي. الكتاب ايش يسوي؟ الكتاب جالس يعطيك طريقة واحدة بس. الكتاب يقول لك أنا عرفت أنه فوق موجب وغصبا عنك تستخدم فوق موجب. يا أخي أنا في هذه المسألة ما أبغى أستخدم فوق موجب. غصب؟ ما غصب.
والمسألة اللي تحتها مستخدم السالب. صح إنه ما صح.
والمسألة اللي تحتها مستخدم السالب. صح ولا غلط؟
صح.
إنزين. It all has to do with your decision. You choose which side is positive, which side is negative, you stick to it. طيب يعني بعطيكم مثال. أنا عندي مثلا مسألة أنا جالس أنا في هليكوبتر وعقيت كرة من فوق. هل في عندي أي شيء في المسألة يصعد فوق؟
لا.
سقوط حر صح؟ من الهليكوبتر بيطيح لين الأرض. زين لو أنا عرفته كالعادة أنه فوق موجب وتحت سالب، معناته الجي مالي بيكون نيجاتيف، والديستنس مالي بيكون نيجاتيف، والفيلوسيتي مالي بيكون نيجاتيف، و60 مرة لازم أضرب نيجاتيف في نيجاتيف، ونيجاتيف تايمز نيجاتيف is equal to positive. طيب من فيكم في حياته ما تلخبط وتلخبط لما كان في عنده 60 نيجاتيف في مسألة حسابية واحدة؟
زين خلي السي ليفل دكتور نيجاتيف.
انزين فأنت ممكن إيش تسوي؟ أنت ممكن أنك تخليها بهالطريقة، ما مشكلة، تخلي السي ليفل 0 وهذا 100 وكل شيء نيجاتيف، أو يا أخي أنا أحط السي ليفل ماينس 100، أنا أحط السي ليفل 100 وهذا فوق 0 وكل شيء صار عندي موجب. Okay. We will do more examples on this later. بس أتمنى أنه الفكرة تكون وضحت، لأنكم لما تقرؤون الكتاب أحيانا ممكن تتلخبطوا. ليش أحيانا موجب؟ ليش أحيانا سالب؟ إيش اللي يفرق ما بين هذا وهذا؟ طيب. طيب. What equations do we use for free fall?
The same.
The last equation.
We use the exact same equations, no change. Okay. We use the exact same equation. طيب. No change whatsoever. إنزين. ولكن there is only one change. بدل A ال A تتحول إلى
G 9.8
ولا شيء ثاني. لأنه it's free fall, so your acceleration is actually G, not A. That's it. أما البقية كله نفس الشيء. Now I looked at your responses to the هذا. We will do one PIQ now. I will split you into groups to discuss about it before we end the lecture. طيب. لكن before I do that, and I noticed in the reading check, a lot of you said you had problems with this problem مع graphical integration مع whiplash injury. sample problem 2.06 و sample problem 2.04. الحين نحن مثل 2.04 سوينا مسألة اللي هي مال السيارتين. طيب ومثل 2.06 أيضا سوينا مسألة اللي هي مال الاريا اندر ذا كيرف. انزين اريد انا بعمل شيء، انا بعمل استبيان. انزين عندكم من الحين لين يوم الاثنين القادم المحاضرة القادمة اريدكم تحاولوا تقرأوا المسألتين هذول مرة ثانية في الكتاب وتشوفوا هل وضحت المسألتين ولا ما وضحت. اريد اشوف هل اللي نحن نسويه في الليكتشر توصل الفكرة ولا ما توصل. لازم نسوي نفس المسألة بالضبط. انزين ما عليها طبعا علامات. It's anonymous. أنا ما راح أعرف منو جاوب أيوة منو جاوب لا. راح أحطه بهالطريقة. You simply need to click sample problem 2.5 و 2. ما أدري كم 2.4 2.6. Do you understand it now? Yes. No. بس. تمام.
اوكي دكتور.
Okay. الحين I want to do this timer. سامحوني. I will take 3 extra minutes from your time after the lecture. بس I really want to do this problem because I find it really interesting. طيب I will release a problem now on هذا. And what I will do is I will split you into groups كيف ما سوينا الليكتشر الماضي to discuss this problem. طيب البروبلم طبعا بيروح من الشاشة بس موجود في الموديل. واذا انتم على التليفون وما تشوفون البروبلم اعملوا التليفون لاندسكيب وراح ينبعث. معظم الاحيان this solves the problem. يلا بسم الله. We try to finish this. Okay. Breakout rooms. Let's see about عشان ما نطول واجد. I will only do it for 4 minutes 4.5 minutes عشان ما نطول واجد. And
the PIQs مستر.
ايوه عندي PIQs حطيت الحين. طيب so hopefully بسم الله let's start. Riyaf and Fatima, I cannot assign you to rooms for some reason. I don't know why. Maybe you're using an unsupported device or you have not updated your Google Meet in your phone or tablet to the latest version. But you can use this as your room because everyone else has left. So for the next few minutes, you can use this as your own room to discuss. Okay, so quite a few people have answered, and I am really happy to see that. Now, Moodle has decided to go. Okay, here I can see the results, but it is already 1:26, so I've already taken 6 more minutes than your lecture allows me to do so. Okay, so what I will do is I will save these answers. Okay, I will save these answers, and at the beginning of next lecture, inshallah, we will discuss, and then we will continue on to the next chapter.
Doctor,
Aywa?
the question number 3. The choices must be there's a positive 10, but there's a minus 10 for the acceleration.
Okay, so you're saying there's a problem with the choices?
Yeah.
Let me take a look.
There we must put 9.8.
ثواني خليني أشوف. في positive 10 وفي minus 10 بعد المفروض.
ما ظهر لي أنا positive 10، ظهر لي minus 10 بس.
دكتور في
أيوة.
positive 9.8.
شيء فالمفروض كيف ما يطلع عندي في positive 9.8 minus 9.8 positive 10 minus 10 و0 و positive 0.2 minus 0.2. اوكي انزين خليني طيب ما مشكلة. I will redo this beginning of next lecture inshallah. We'll redo this. We will hi.
Doctor, what's his answer?
Sorry?
The correct answer.